Our today's topic is basic concept of calculus. So let's start with the definition of derivative. 1. The instantaneous rate of change of one variable with respect to another variable is called derivative of function. Geometrically, the derivative is the slope of curve at the point on the curve. The process of finding the derivative is called differentiation. Next is rules for differentiation. Rule 1. Derivative of constant function. If f has constant value f, x, equals c, then d by dx, c, equals 0. Example: y equals 3, y equals 0. Rule 2. Power. The power rule in calculus is a fairly simple rule that helps you find the derivative of a variable raised to a power, such as x5, 2x8, 3x, minus 3, or 5x, a half. If n is integer, then d dx xn equals n xn1. Let's take this example. F x equals x4, f x equals 4x cubed. Rule 3. Product rules. The product rule is a formal rule for differentiating problems where one function is multiplied by another. The rule follows from the limit definition of derivative and is given by: if u and v are differentiable at x, then so is their product of and d dx uv equals u dot dv dx plus v dot do dx. Rule 4. Quotient rules. A special rule to find the derivative of one function divided by another. This rule, called the quotient rule. If u and v are differentiable at x and if v, x, 0, then the quotient uv is differentiable at x, d dx uv equals v, do dx, u, dv dx, v2. Rule 5. Chain rule. The chain rule is the formula for computing the derivative of the composition of two or more functions. Di dx equals di do dx. Basic concepts of integration. Start with the introduction. When a function f(x) is known, we can differentiate it to obtain its derivative df by dx. The reverse process is to obtain the function f(x) from knowledge of its derivative df dx. This process is called integration. Applications of integration are numerous, and some of these will be explored in subsequent blocks. For now, what is important is that you practice basic techniques and learn a variety of methods for integrating functions. Next is integration as differentiation in reverse. Suppose we differentiate the function y equals x squared. We obtain dy dx equals to x. Integration reverses this process, and we say that the integral of 2x is x squared. The situation is just a little more complicated because there are lots of functions we can differentiate to give 2x. Here are some of them: x squared plus 4x squared, 15x2 plus 0.5. Here are some integration formulas to remember. Our today's topic is basic concept of calculus.
Created using Powtoon.